atomic bomb, an explosive device that releases nuclear energy. All previous explosive devices were powered by rapid burning or decomposition of a chemical compound. They only release energy from the outermost electrons of an atom. Nuclear explosives are energized by splitting an atom, a process called fission. On July 16, 1945, the first atomic bomb was detonated at 5:30 a.m. The resulting implosion initiated a chain reaction of nearly 60 fission generations in about a microsecond. It produced an intense flash of light, followed by a fireball expanding to a diameter of about 600 meters in 2 seconds, and then it rose to a height of more than 12 kilometers, forming its ominous mushroom shape. 40 seconds later, an air blast hit the observer's bunker, followed by a sustained and an awesome roar. In August 1945, the United States dropped atomic bombs on Japan over the cities of Hiroshima and Nagasaki. The Hiroshima bomb, using the code name Little Boy, had a force of 13,000 tons, or 11,791 metric tons, or 13 kilotons of TNT. Its element base was uranium-235. The Nagasaki bomb, using the code name Fat Man, had a force of 22,000 tons, 19,954 metric tons, or 22,000 kilotons of TNT. Its element base was plutonium. In 1949, the Soviet Union tested its first atomic bomb, followed by Britain in 1952, France in 1960, and China in 1964, India in 1974, and Pakistan in 1998. The hydrogen bomb, or H-bomb, is a weapon deriving a large portion of its energy from the nuclear fusion of hydrogen isotopes. In an atomic bomb, uranium or plutonium is split into lighter elements that together weigh less than the original atoms. The remainder of the mass appearing as energy. Unlike this fission bomb, the hydrogen bomb functions by the fusion or joining together of lighter elements into heavier elements. The end product again weighs less than its components, the difference once more appearing as energy. Because extremely high temperatures are required in order to initiate fusion reactions, the hydrogen bomb is also known as thermonuclear bomb. The major difference between the hydrogen bomb and the atomic bomb is the atomic bomb was made through nuclear fission, which is the splitting of an atom, and the hydrogen bomb was made through nuclear fusion, which is causing the nuclei of the atoms to join together. Since the fusion reaction produces mostly neutrons and very little that is radioactive, the concept of a clean bomb has resulted. One having a small atomic trigger, a less fissionable tamper, and therefore less radioactive fallout. Carrying this progression further would result in the suggested neutron bomb, which would have a minimum trigger and a non-fissionable tamper. There would be a blast effectives and a hail of lethal neutrons, but almost no radioactive fallout. This theoretically would cause minimum physical damage to buildings and equipment, but kill most living things.
Those within approximately a 6 square mile area will indeed be close enough to the center of the blast to be killed by the gamma rays emitted from the blast itself. Ghostly shadows of these people will be formed on any concrete or stone that lies behind them, and they will be no more. They literally won't know what hit them, since they will be vaporized before the electrical signals from their sense organs can reach their brains. Outside of the circle where people will be instantly vaporized from the initial gamma radiation blast, the light from the explosion, which is many times hotter than the sun by the way, is so bright that it will immediately and permanently blind every living thing, whether their eyes are opened or closed. This will happen for about 10 miles around in every direction for a 1 megaton bomb. Obviously, for a larger area, for a bigger bomb. Further, for those who happen to be looking toward the blast at the moment of the detonation. Even from 15 miles away, a 1 megaton blast will be many times brighter than the noonday sun. Those looking directly at the blast will have a large spot permanently burned into their retinas where the light receptor cells will have been destroyed. The huge bright cloud being nearly instantly formed in front of them, made in part from those closer to the blast who have already become death, or dead, will be the last clear image that these people will see. Most people who will die from the nuclear explosion will not die in the initial gamma ray burst, nor in the multispectral heat blast, which is mostly X-ray and ultraviolet wavelengths, which will come about a tenth of a second after the gamma burst. Nor will the pressure wave, which follows over the next few seconds, do most of them in, though it will cause bleeding from every orifice. Nor even will most people be killed by the momentary high winds which accompany the pressure wave. These winds will reach velocities of hundreds of miles an hour near the epicenter of the blast. It will reach velocities of about 70 miles per hour as far as about 6 miles from the blast, for 1 megaton bomb. All this is about 1 megaton bombs. The high winds and flying debris will cause shrapnel-type wounds and blunt trauma injuries. Together, the pressure wave and the accompanying winds will do in quite a few and damage most of the rest of the people, animals, and structures in a huge circle, perhaps hundreds of square miles in area, which is pretty big. Later, these people will begin to suffer from vomiting, skin rashes, and intense, unquenchable thirst as their hair falls out in clumps. Their skin will begin to peel off. This is because of the internal molecular structure of the living cells within their bodies is breaking down as a result of the disruptive effects of the high radiation dose they received. All the animals will be similarly suffering, since they have already received the dose. These effects will show up even if the people are immediately evacuated from the area. Many of the survivors of the initial blast of a nuclear bomb who do not die in the following firestorm will die painfully over the next few weeks, often after a brief, hopeful period where they appear to be getting better. It might begin as a tingling sensation on the skin or an itching which starts shortly after the blast. These symptoms are signs that the body is starting to break down internally at the molecular level. The insides of those who get a severe dose of gamma radiation but manage to survive the other traumas, whose organs had once been well defined as lungs, livers, heart, intestines, etc., begin to resemble an undefined mass of bloody pulp. Within days or perhaps weeks, the victim, usually bleeding painfully from every hole and pore in their body, at last dies and receives their final mercy. But this too will probably not be how most victims of a nuclear attack will die. A significant percentage, probably most of the people who die from a nuclear attack will die much later, from the widespread release of radioactive material into the environment. These deaths will occur all over the world for centuries to come. Scattered deaths in pockets of higher mortality rates will continue from cancer, leukemia, and other health effects, especially genetic damage to succeeding generations. Nuclear weapons do not recognize the end of a war, or sign peace treaties, or even the deaths of all the combatants. They simply keep on killing a percentage of whoever happens to inhale or ingest their deadly byproducts. Some deaths will occur hundreds and even thousands of miles away because low levels of ionizing radiation are capable of causing the full spectrum of health effects, albeit at a lower rate within the population. Not to mention the radioactive runoff from the rivers and streams that flow through the blast area and the area under the radioactive mushroom cloud's drift. It may carry its deadly cargo for thousands of miles, raining a fallout of death only on some cities and not on others. We are now going to end this presentation with a short video clip.
In the days and weeks that follow, clouds of soot enshroud the Earth. Temperatures plummet. The planet is gripped in a nuclear winter.
As these smoke clouds move out and prevent sunlight from reaching the surface, temperatures will rapidly begin to drop. We already know from our everyday experience that at nighttime, when there's no sunlight, it gets cold. And it would only take a few days for the loss of sunlight at the surface to drop temperatures in the continents to sub-freezing temperatures.